Okay, thank you, Stefano. Okay, so for the benefit of the people on the Zoom call, we've been chatting in the room amongst ourselves. I've done a bunch of introductions and stuff which you've all missed, so I apologize. This meeting has not been, this meeting has not been optimized, originally planned to be a hybrid meeting, but it was last minute thing. So next time, I think for a hybrid meeting, there's other things I do logistically to make it better. But we are recording this because some people want to come but couldn't make it. We've had tons of problems with AV, but now we think it's well worked out. So with that, we're actually not terribly off schedule just yet. I think I'll throw it over to Dave, and just we'll dive into it. So like I said, it'd be great if this is interactive. Dave, if you want to hold questions, you feel free to say so. If not, just have a discussion. That's different from when you do someone does a webinar. You just don't get those same kind of interactive. So that's a benefit of this kind of forum. And for the people on the remote, hopefully this mic picks us up, and if it does, great. If it doesn't, sorry. So Dave is the Director of Software Engineering in Digital and Automation and everything else that smells like that at Tessera Therapeutics, and has done a lot of different applications, but today is going to sort of focus on some of the application architecture for the back end and how to use Retool as a front end and just some experiences in that area. So I'll let Dave take it away, and thanks so much, and let's see how it goes.
So I'm a very casual person. Feel free to interrupt me at any time with any kind of questions. I have just a few slides to sort of drive home sort of some of the messaging and experience that we have had at Tessera regarding sort of, like you said, augmenting the capabilities of benchling. One of the things that I always tell people is that benchling is and always will be an ELN. I think it's trying to make some roads into be more like a LIMS, but it's still not quite there. I think it's great that it has like the APIs and has very structured data, and we sort of leverage a lot of that to sort of make some companion apps for benchling that are driven to make our system more like a LIMS. So it's a hybrid between some custom software, some off-the-shelf software, and benchling to sort of make the whole thing go together. So this is sort of the 10,000-foot view of the architecture. So we have benchling. That's a typical SaaS product. We all know it, and it has a very rich set of APIs, which basically allows you to do pretty much anything you want to do, from a custom entity, plates, managing any kind of data, assay results. It has a very rich library. And the iceberg here is sort of our main integration stack. So Retool, which I'll talk a lot about, is a user front end for building applications. It's called the low-code front end. And it has basically a drag and drop system to configure user interfaces. So you don't have to do the typical writing of HTML, and CSS to sort of build those things. But it also allows you to configure tables and forms and all sorts of input and data displays that can be connected to either backend databases, such as you could connect it to the Benchling warehouse. It also allows you to connect to APIs. And that's where we have sort of the tip of the iceberg is just the thin layer of Retool for the user interface that we give out to the lab folks and scientists. And then below that is the big architecture of Tessera Message Broker, which is basically housed in our secure network. And I'll get a little bit into what that is. But the Tessera Message Broker basically communicates to our analysis pipelines, it provides the data for our NGS pipelines. It pulls the data from Benchling, formats it in a way that's user-friendly for our APIs. It transfers it to our Nextflow or Dagster sort of analysis pipelines that the comp bio folks will work with. We also use the broker to not only talk to the analysis pipelines, but also to the automation that we have in the lab. So we have it talk to our Hamiltons, for example, when the Hamilton starts up and starts processing things, it sends API calls to our message broker, and that stores the data in a database, a relational database. But it also would pull data from Benchling and push that information also to our lab automation. For example, cherry pick lists and work lists and other things that we need to drive the steps on the Hamilton. All this sort of feeds into our science, our machine learning, and everything that goes downstream for our analytics. But to talk a little bit more about this is, like I said, everything is hosted in AWS. We use a framework called serverless to build our infrastructure, which means it's an application framework, but it's very good at building AWS infrastructure in Lambda functions. So we use Python as our main coding library. We use the serverless framework that allows us to stand up things like Lambda functions, API gateways, load balancers, so to build all this sort of underlying infrastructure that happens there. And that gives us a whole set of APIs that we use to, again, talk to Benchling and then push that data to other parts of our system. Largely the application of the test motion broker is stateless because we push all the data back into Benchling. There's some operational data that we have, but largely everything goes back into Benchling, especially the scientific data. So if we give the users the ability to create a plasmid or create some sort of scientific entity, we might have the user interface in Benchling, in Retool, because we can have more validation that we can do. We can do lookups, we can create complex objects, we can do bulk registration, we can do all those sorts of things in a much more streamlined capacity than some of the workflows and some of the user interfaces that are provided with Benchling out of the box.
Maybe, I think you probably get to it, but one of the features you mentioned about the serverless framework is it's also able to push containers.
That's right, yeah. So sometimes they're just Python, we use Python sort of Lambda functions, and sometimes we use containers for some of the more complex workflows, such as things that involves NumPy, some of the larger Python frameworks. So it gives us basically the capability to build all that stuff with CI/CD and continuous integration and code configuration as code. And here's just a small example of the Retool interface. This is a pretty stripped down version. If you're handy at CSS, there's a ton of customization. The things I like about Retool is like I said, it's a drag and drop, so you can make the tables by saying, I want a table here, and then you can feed the data that goes into the table from an API or query calls, and then you don't have to write all the CSS. But if you want to write CSS, if you want to write JavaScript, you can create as rich an application as you can imagine. It's basically, I find that if you can do it in a web application, you can do it in Retool, but you don't have to build all the infrastructure around it. You still have to build all the code that goes into the back-end APIs, I write quite a bit of JavaScript in the front end to create more visual user interfaces, and I'll show a little bit of that. This is just an example of a simple web page that we did for the science team. There we go. So this is just an example of what a developer's user experience is when they're developing a Retool app. You sort of, say I want a text input. You can add a button, and these are all building out forms so that you can capture user input. Pretty typical of a lot of these low-code tools. And this is kind of limiting, right? It's just a simple form, but it's not sort of the experience that a lot of scientists need because some of their needs are not just simple forms. So by building out more stuff with JavaScript and stuff, we can build really rich forms. But in the back end, this shows sort of all right, you have a form now, you have a button in a text box, and in the background you would say, all right, this is the URL for your API. You set it up as a resource. You basically can take the input parameters for a text input and pass it as a GET function to that to pass data back and forth through an API, and it'll retrieve the data. If it's a GET, it can retrieve the data, you can display the data. But that's a simple example of a sort of a round trip of saying, all right, I drag and drop this form. I have an API in the background. That API call has code that has its own API call to Benchling to pull some information, and then it passes it back to the user interface. So that's kind of the round trip of how you would configure all this stuff. And like I said, text boxes, buttons, forms, those are nice. But like I said, we do a lot of customization of it because we do have, I'm a software engineer. I have 2 engineers on my team. We're basically full stack engineers. We use Retool basically because we don't have to build everything by hand. We can build a Spring app or something like that, but this makes it a little easier. So the thing that makes Retool great is it has an iframe capability that you can basically write JavaScript, HTML, and anything you want into it to create really rich user interfaces. Some of the sequencing library, some of the JavaScript libraries we use are like SeqViz, which is a library. I don't have a demo of that one, but SeqViz is a library, a JavaScript library that lets you visualize plasmids and being able to select regions of it. So we have the ability to annotate sequences and then push that information into Benchling. It's still in a very prototype stage, but we want to augment some of the ways that we do sequence annotation at Tessera by not only having like annotations of regions, but having categorization of regions too. So creating another layer of complexity on our user interface while still storing all the information in Benchling is sort of how we're sort of augmenting Benchling's capabilities. This is a example of a plate mapping tool that I built. It's basically using a JavaScript framework called InstaTable. As you can see, the user can paste things in a very Excel-like fashion into this. And I know there's a lot of interfaces like that in Benchling. This gives you sort of basically the ability to drag and drop and use it as Excel. You can also, we've added some like right-clicking capabilities. So if you have a list of numbers for concentrations, you can like highlight a region of the frame, and you can right-click it and say this is nanograms, and it basically will decorate all the entities as a number and a unit. This is fully programmable, so it's all JavaScript. I can write it all in JavaScript. I can build all sorts of capabilities. We're using it for a lot of high throughput plate stuff. So if we're using these to like add 10 plates of something, they want to plate it all out and how it all looks. They can upload an Excel file into one of the user interfaces, and it basically does this sort of transition. And if you see the transition from the white, and then it goes to green or red, it's basically every one of those is a callback to Benchling to validate that those are real entities and that the right type of entities that go into this type of workflow. So it gives you kind of a visualization of you doing the right thing. I think one of the biggest issues we've always faced with Benchling is this limited validation you can put on the front end. And I'm of the strong opinion that if you want good data in your database, which is our Benchling instance, you should validate the data before you put it in, because it's easier to validate it on the way in and correct mistakes than try to fix the mistakes after the fact, right? So this is a new capability. This doesn't really look, this looks kind of washed out on this slide, so I apologize. One of the things we're currently doing is in our Tessera message broker, we're introducing a new capability, which is a workflow engine. And this is where we're really talking about having it be more like a limb system, because one of the things that we find that Benchling doesn't do well is workflows. I know it has a workflow capability. It doesn't really suit our needs. We are very complex. Their workflows tend to be very linear. As you can see here, though, we're using Camunda, which is a workflow engine as part of our infrastructure. This gives us the ability to configure a workflow and be able to upload it into our Camunda database, which we are standing up. We have a separate database, a separate app. The users don't have to interact with that. They use the retool interface, but we can show a process map and have, different steps. We have different tasks. We have like, we can create task definitions. You can assign them to users. They can be user tasks. They can be API tasks, or they can be like service tasks. So each of these different types of tasks you can track. And one of the nice things about it is if things go through this process, through the steps of the task, it records start times and stop times. So if you're in an environment that you're sort of doing borderline manufacturing, turnaround time is one of those things that people always want to know. So getting this will track all the turnaround times for each process and steps. So we're building Gantt charts and stuff like that, so keep an eye on the processes we do. And this is largely configured, but what we do is we build a form, the users put in something, it kicks off a process, and then people get queues on each one of these steps, and those queues might have forms associated, just like, all right, this was a GDNA that we extracted, just for a dumb example. And we can then say, was the GDNA have enough concentration? We can make a rule that says, yes, it's above a certain concentration. And then we have what, if you see the triangle, well, it's not really a triangle, it's a square with the next to it. That's called it's like a decision point. It's called a gateway, and then we can branch off onto different parts of the workflow based on different logic. So you can imagine that if it's in the first step of the genomic library prep, and we have an API that uploads the GDNA quant, we can mark it as a rule and say that the quant was above a certain level. We can automatically push it to the next step and fork it based on business rules to sort of manage how things flow through the diagram. So this is a combination of using Retool, Camunda for a workflow engine, and then the custom code and Tessera message broker to orchestrate all of this. We've often talked about bringing in a separate LIMS, but all of our main scientific data is already in Benchling. If we were to bring in the LIMS system, we'd still have to integrate that system because ultimately that's our source of record for Benchling, and we do use a lot of process-oriented things in Benchling. So this is sort of a way we're sort of augmenting Benchling to make it more process-driven. It will drive more things like chain of custody and stuff through these processes by having a more constricted process, rather than what Benchling really is, which is much more open and much more fluid. So having that sort of infrastructure allows us to stand up workflows quickly, allow people to like interact with those workflows and drive the process, and then we can trigger events. We can have this trigger pipelines. We can trigger automation. It's all a matter of configuration and writing the proper connectors and the code that goes with it.
I think maybe just one distinction. So at Tessera, there is actually fairly extensive use of benchling workflows. And for example, it's very successful in the analytics requests and fulfilling sample analytics and so forth, which is a little bit more of a simple case. On the other hand, when we're at the foundry is trying to make zillions of RNAs of different types and different mixing all these different batches, and there's just so much going on that when you're trying to do that workflows, it's like you keep kind of hitting the edge, and then at some point you say, we kind of just need to be able, instead of having something that we can kind of tweak a little bit from the outside, we have to sort of be able to control that whole manufacturing process, and then treat benchling as sort of we'll get the results, and when we finally get something done and put it in inventory, we'll put it into benchling. But you can hear like some of the things Dave talked about, there's just so many different things to do that the software kind of gets to be easy when it's in the code. And without having benchling, open source benchling, it's really kind of, you had to go to this route for this kind of use case. It's just that dynamic.
Yeah, we want to use this like for things like loopbacks, right, and rescue, right? If you go through a process and it fails, a lot of times you have a separate process to rescue a sample to get it to where it will pass. So having sort of splitting, redo loops. Camunda also has this the idea of swim lanes. Where swim lanes work, you can think of each swim lane in the process map being a different team. And then when you have tasks that span over a swim lane, you can actually assign tasks to different groups. So you have that with the trigger to say, now this goes to a different team, it basically gets a notification or something, and then they go to their queue to work them. So these is, that's basically all I was really going to talk about. It shows some of how you can really build a whole ecosystem of applications that sort of where benchling is sort of the center of what your work is and what your data sources is. But with custom development, some good engineering, some good tooling around retool stuff. Yeah.
Yeah, so this benchling is totally new to me, but
Yep.
I just want to learn what this tool can be used for. So I have two questions for you after listening to it. One is for the kind of a custom application you build, are you using it internally or you actually also sell as a service? The other thing is, like this kind of tool, in terms of it is used in a commercial production of like RNA, or it's more for laboratory. So that's two things.
Yeah.
I'm naive on those aspects. So it's probably
Yeah, no,
a
totally.
question that I'd like to learn about.
Yeah, so we use these tools only internally. So, like benchling is a software as a service product. All of these tools are in our AWS environment. We self-host our retool into our own environment, just because I didn't want to deal with privacy information. They do have a retool software as a service offering, but we stick with the self-hosted. This is sort of bespoke and built to our specific needs. It takes some software engineering, so it's sort of like I'm sure we could spin up a company to do consulting on building these sorts of things. But I think this is where benchling is, like when you're talking about like the unstructured data, that like using it as an ELN, you really don't need a lot of augmentation when you're doing that, because that's where benchling is strongest, right? Benchling is a really strong ELN, and it has great like discrete data capture, which you can do through notebook entries. But sometimes when you're doing at scale, or if the dimensions of the data are really complicated, it becomes more difficult. One of the things I always say about benchling is that one of the issues is the data model is also the user interface, right? So how you model your data is how it is presented to the user when they're basically entering the data, versus having an application like the retool stuff that we do, which is like a layer of abstraction, so that we can build the data model be more computational friendly and more sort of classic software engineered databasey, versus and be able to push the data in through a simpler user interface. So my advice is usually, if you're just looking to do ELN stuff, benchling is probably all you really need. If you need something that needs to be more like a LIMS, and like you were saying, like a manufacturing process, like which we have, like we have a team, it's called the Foundry, they make lots and lots of RNAs. They use benchling, but it's not meeting all of their needs. One of the things they need the most is being able to say at any given time, where is a request? Like if one department requests a manufacturing of an RNA, where is that? And it's difficult to do in benchling. What you need is a process flow diagram, like the Camunda stuff and all of that infrastructure to sort of make it more structured and create Gantt charts and all this other stuff. Yeah.
Okay, so given what you're just talking about, how like the data models and benchling rankings are defined, where do you I guess store the code for interacting with benchling? Is that all done like on one-offs and these kind of user-facing tools in JavaScript, or do you have like a centralized library that has all the data models, all the interactions between all these different entities and API calls to it? How do you manage all that?
Yeah, so the tester message broker has a lot of the business logic. So we built our own connector. You can use the benchling SDK, which makes some wrappers around calling their APIs. But our message broker, that big AWS infrastructure, a lot of the stuff we do is in Lambda functions. So we have libraries for making connections and pulling specific entities, and then we capture like business logic. Like one of the things we do is we create a sample sheet for a Illumina sequencer, right? So the user the user goes in and selects the tubes that they want to be included and pooled onto the sequencer. We know what's in it because the tubes are in benchling and we know all the entities in benchling. But what it does is when they submit the request to make a sample sheet, it hits the AWS Lambda function. That function basically starts calling the APIs to like pull all the data. but it will also do a uniqueness check on the indexes, right? Because if you have the same index in the same lane, you will not be able to separate those the reads per sample. So we have that business logic. That's almost impossible to do in benchling, is to be able to go through every tube, look at every sample in the tube, to look at the PCR product, and then look at the index on it, and basically do a uniqueness check across the whole lane, right? So that's where that happens. If it comes with an error, it basically lets the user say, you have conflicting indexes, you need to move them to like different lanes or on different runs. But if there's no issue, it basically spits out the index sheet. You store it in S3, but give them a download of it so they can bring it home to the augment. So that's kind of how it works in a real case example. But yeah, it's all in Git. We all use the serverless framework to push our functions to the database.
So I'm curious, you said you use Benchling basically as your database. I'm wondering, like, I think, does Benchling like run into any performance problems as you get to large numbers of entities? Like I imagine you have many RNAs.
Yep.
Like what's the largest number of things that you have?
So yeah, this is where our architecture really plays. So a lot of the user interaction stuff for the user. So when the user is in vTool and they're interacting with that, usually they're just calling APIs like the Lambda functions. But if we have a thing that creates a lot of calls to Benchling, so we can register templates at a time that have like 5 or 6 different custom entities that basically combined into a new entity for each one of them. On average, that takes about 200 to 300 Benchling calls. So the way that works is that we use Fargate to offload that. So basically, they submit a request by filling out all their information. It goes off to Fargate. It runs as long as it needs to. We build in throttling so that we know the limits of the API. So we back off the throttle so that we don't hit those limits. When the process is done, we send a Slack message to the user saying, your request has been processed. Here's a link to go get your information. And then they can click the link, and it might bring them to Benchling, it might bring them to another page in Retool, it might let them download a file. So that's kind of how we do it, to sort of work around some of the limitations of performance.
And just in case anyone doesn't know, Fargate is AWS's serverless Docker.
And there's really no limit on how long that can run. So
I guess my question is, how do you manage authentication and permissions for different users having different capabilities within the ecosystem?
yeah,
So could you just read back the question, because I'm not sure if the mic will pick it up in the back of the room. So
yeah. So he was asking how permissions will work when it comes to users. So yeah, Retool actually has has users and groups associated to them. So we basically authenticate them with single sign-on. So they get an Okta tile, they click in, they have different groups that they're associated to. They get app permissions to specific apps based on their role in the company, and that allows them to interact with a specific app. And that app basically has certain functionality, and they can use basically any APIs to call it. In the backend, we use AWS secrets to pull tokens for the Benchling authentication, generate a token to do that.
So do you have a single user or like single machine user that interacts with Benchling?
Yeah, that's how we do it. So there's a single user in Benchling that does all the interaction. However, if you want to, we also pass in the user email address from the Retool, because that's just something we have as part of the user credentials in the system. We pass that all the way through to Benchling sometimes, depending on what, and you can set an actor on some of the API calls to say that this person did this thing rather than the message broker did this thing. That's not available universally, I don't think, but that's what we try to do when it's available.
and remind me, the message broker is using the Benchling app credentials?
That's right.
Yeah.
Yeah, so it uses OAuth.
I think you mentioned that at least with the automation, you did have a relational database that is sort of acting as a middle. Is that just for the automation, or are you doing anything in terms of like snapshots or anything from the data that's being pulled from Benchling?
We talked a lot about pulling snapshots from Benchling. It's something we want to do. The warehouse is great to have, but we write the same queries over and over. It's great to be able to add some views, it's great to be add some indexes, and we just don't have that with the Benchling warehouse. The database that I was talking about is actually part of the retool. So that's completely separate, and we tend to just store operational data in there. That way we like the robots basically sending us time, start and end times and stuff like that. But all the scientific data is pushed to the Benchling.
And as a principle, right, the system of record is always Benchling, except for like the big things like primary NGS data, things like that that might stick in Quilt, we use as well. But, so sometimes stuff gets copied out, and if we stand up this extra warehouse, that'll just be a read-only snapshot. So,
Yeah, we've been talking to AWS about that too. See if they have some ETL stuff that we could leverage.
more questions today?
So, you see, we use the workflow. So, generally, actually, running the workflow will take time. And
Yes.
so, I was wondering, like, can you give a rough estimate or are they on workflow? And then how actually what is the time to realize?
Yeah, no, that's a great question. You're absolutely right. Finding it is, so the question was, how long does it take to implement and to design a workflow in the retool? So what we're using Camunda in the back end as the engine. And Camunda is a standard business process model application, which means you can use BPML documents to design it. So there's a user interface, there's a desktop app you can download for Camunda. It allows you to drag and drop basically the workflow and say that this is a user task, this is a service task. That's actually, if you know what it is ahead of time, it takes like minutes, half an hour to like put it together. That's the easiest part. The hardest part is, the parts that take time, is defining what that is, because the users don't always know. They kind of loosely know what their workflow is, especially if they've only been using Benchling for a while and they haven't been in the rigor of doing a real process. That's the one thing. And then figuring out what are the callbacks and forms you want to capture on each of those steps. So like if you have a step and it's like, I need to upload a quant data on this step, building the API to take the quant data and parse it and say, yes, this should go in this direction. All those little things are the things that really take time. So you're right, it's the definition of it and the API interaction. The engine itself is pretty straightforward. Yeah.
So is it also like, so here's the, here's my idea but is it like him or like what we found like a struggle is
Oh, yeah.
and then also control the user function database, and sometimes it's not online. So I don't have information for the app, I don't have information so.
Oh, I see. Yeah.
Especially for aspect.
Yeah, I mean, so the question is the permissioning of like the Benchling data versus the retool data. That's why we use like a super user for the interaction between Benchling and retool. So it basically has permissions to read basically everything. And then we have a separate layer of permissions. But you're absolutely right. If you set up certain permissions in Benchling to restrict data access to this thing, I don't know of an easy way to mirror those same permissions in retool. You have to basically capitulate that. One of the things that we're doing, and it's coming in the next version of retool, is not only doing authentication of users and basically, but also doing, because right now the version we're using does last minute user provisioning, but the next version also allows you to manage the user groups and roles from your single sign-on source, so that you can assign all of the single sign-on users to different groups. I don't know if Benchling has that capability, but at least we're moving the permissioning out of Retool as a first line of configuration back to our SSO authentication platform, right? I think it's a step in the right direction, but like anyone who's dealt with Benchling from an admin knows how complicated the permissions are in Benchling. And I don't want to have to try to
And I can probably answer part of that question is that the majority of the data that we have in Benchling is open to the whole company. There's very little that we restrict. So we don't run into these issues of permissions, so people can see these types of data that they can't see others. So the base user that the tool uses has the same permissions that users.
Yeah, so the good solution is when you don't have to protect anything, then go across the border, it's not a problem. I just wanted to sort of amplify this point because sort of the theme of today is sort of these integrations. Once you leave the walls of Benchling for anything, whether it's this or any kind of integration, there's always that chance, especially when you start pulling stuff into a data warehouse or something, that you've erased any permissioning. And I've seen this multiple times, where all of a sudden someone's got this warehouse and have access to everything because they filled it all over. And so it's a design consideration when you bring something out to think, do I care? If we don't, or if I do, what's my mechanism going to be? In fact, you could go better. You could have row-level data protections, which is hard to do in any system. Or you could do a lot worse because you've now leaked something because everyone's got these credentials onto this handy warehouse in Tableau to do reporting, and all of a sudden they see all these things that used to be protected. So I think it's an important sort of non-functional requirement to keep in track whenever you're building some of these integrations, especially ones that move out blocks of data. Anything else for Dave? Yeah.
Hi. I'm just wondering how much sort of permanent infrastructure do you run these spots for?
Well, that huge diagram. Yeah, so it's a couple dozen Lambda functions, a load balancer for a production system, all the API gateways for each, an API gateway for all those. We're not really doing anything with RDS because we have something for the retool part, but it's tiny. Everything is serverless, so I'm like, my costs from an infrastructure is like in the margins of what we spend in AWS because we have machine learning and all that stuff. I literally, this infrastructure costs us hundreds of dollars a month in infrastructure because we run everything serverless. It's not being used, it's there and we don't pay for it. And I'm cheap, so that works out well.
Awesome. Well, thanks so much, Dave. That was great. So I don't know how we're going to do.
I think whoever is next should just share their slides on Zoom, and I'll share.
Okay.
The Zoom
Yeah,
page.
just keep that.
I mean, you also just let me Zoom.
Yeah, so if you can share, you should be able to. Oh, there you are.
Let me.
Yeah. Yeah. So you're on Zoom now, and so Dave will keep his vital link to our Crestron.
It won't show. Yeah, so sharing from Zoom, it'll show that. It won't show.
But I'm sharing my screen.
Oh, the yours.
Right. So just say keep that.
All right. You want an introduction, or are you going to introduce yourself?
I can introduce myself.
Okay.
Second. All right. So, can everyone hear me in the back? All right. So my name is Patrick. I work at Sail, which some of you might also have known as either Laurent or Senda. We were relatively recently merged. Well, I say that, it's actually almost a year now. And I'm here to talk today about our almost mirror image of what David just showed you, our Benchling integrated custom digital backbone. So let's get started. So at Sail, we combine two great tastes that taste great together. We work on programmable pharmacology using both what we call endless RNA, which is a fancy way of saying circular RNA, and mRNA, combining that with nanoparticles, either natural nanoparticles or synthetic, and putting them together to create some wonderful integrative generation of RNA medicines with just a sprinkling of AI marketing in there to spice things up. So to do this in practice, we have people will propose genetic sequences, and there's all sorts of ways that they'll come up with these sequences, putting together multiple different building blocks of parts to try to combine those with ORFs, all of course to try and get therapeutic results. We'll take a large number of these trials, test them in, at a small scale for automation. So it's small scale, but it's a large number, so it's high throughput. And then for some of those that look good, we then go to doing mid-scale in vitro and in vivo testing. And of course, when any of those look really good, we then have to scale them up for clinical manufacturing. So this is the overall process of what the company does, and the part that we're talking about today is, of course, the digital backbone. So some of the things that our digital backbone does. And this is irrespective of what we actually use to implement the digital backbone. So we needed to be able to help them design different parts of the sequence, like I said earlier. So they need to be able to create sort of functional subparts of the construct. They need to be able to input their designs for ORFs and for constructs. And through all of this, we need to avoid accidental repetition. So we want to make sure that if someone created this, ORF 1, 2, 3, 4, that doesn't end up being the same as ORF 2, 4, 6, 8 just by accident. If we test it, we want to know we tested it before or we haven't. We want to track manufacturing. So we're doing part of the job of LIMS. So we're keeping track of the manufacturing of the constructs through various different processes. We're keeping track of the formulations with the LNPs. And we help manage the supply of the constructs through integrations with cold storage. And we also keep track of the quality. We need to keep track of quality control. We also need to keep track of various integrations. So we want to be able to get DNA synthesized. We want to integrate with automation instruments such as the Hamilton. We have storage instruments for cold storage, the Arctic and the Compound. And we also, of course, want lab notebook integrations, and we want to be able to confirm sequences. That is to say, we want to be able to get sequences back from various different vendors. So last and most recently, we're also starting to manage priorities. So this is a bit of a fuzzier domain. So we help create a system for balancing the different demands, both from the users and the people actually producing the material. And then through this process, through creating and formalizing this process, we can add transparency to these customers, the people who want constructs, and transparency to the leadership who wants to know, why various projects might be held up or why various projects, how they can move a certain project forward more quickly. And of course, by having this all integrated with the rest of the backbone, it gets to be for free. We get to integrate with everything else. So this is what we need. And ideally, we would also like an ergonomic user interface for all of this, because at the end of the day, if your application isn't easy to use, people aren't going to use it. And as I'm sure many of us know, one of the core challenges in this domain is actually getting people to use all of the stuff that we have so carefully and painstakingly designed. So at the end of the day, it's not the solution, it's the challenges you meet along the way. So how did we end up with the particular system that we have? Let's walk through it. So the first thought was, of course, let's just work with Benchling. But there's a few things that Benchling didn't supply that we really needed. So we really needed to be able to, like I said, keep track of making sure that nothing is repeated accidentally. So we have custom measures of uniqueness. It's not necessarily just that a sequence is unique, but it could be that various aspects, a combination of sequences is unique, right? So if you have an ORF and several other parts, it could be that combination of ORF and parts that's unique. And in principle, there could be actually sequences that are identical, but which have different constructions. And that's something that is still distinct in that we want to keep track. We also want to keep track of the manufacturing tracking. So as Sten mentioned, Benchling isn't really a limb system yet. We want to be able to execute rapid operations on many different entities, many different constructs. So as has also been mentioned, often when you try to access many different things within Benchling, you end up with many requests that take a very long time to execute. And we want to try to avoid that. And last but not least, perhaps more subtly, but also very importantly, we need the ability to control the kinds of things that users can input. We want to help guide the users through that input. So we want prompt feedback. If something that they're trying to put in there is wrong, if it doesn't make sense, we want to be able to tell them immediately. We want to be able to conditionally choose which inputs are allowed. So if they select one parameter, that can affect what other parameters are available, depending on, say, the type of construct. Are they doing eRNA or mRNA? So with all that in mind, our first approach was to use AWS Amplify, which works on the API Gateway and Lambda, and Amazon DynamoDB. So this had some shortcomings. In particular, Lambdas can be a bit slow to respond initially, which can also become problematic if you make multiple requests. We wanted a native Python REST framework, which makes it easier to test. So we can just run the application locally or in a Docker or wherever, and we can test it live. We wanted some more Dockerization. And a big one is that AWS Amplify is just glacially slow at doing releases. So if you want to release a new version, it just takes a very long time because it does everything from scratch. And in terms of DynamoDB, it was really nice to set up very quickly, and it offers more flexibility than Benchling in terms of data models, but ultimately it still didn't offer us enough flexibility, and it wasn't very performative for what we wanted to do, and not as many people are familiar with it. So where we're at now, we have GitHub Actions, which manages our infrastructure using API Gateway, ECS, and Lambda. So ECS is essentially lets you run Docker images on a flexible computing environment. So it's not quite as on the fly as Lambda. You always have a server running, but you don't have to sort of manage the details of the server. It launches it, and if one fails, it'll launch a new one. It's, I believe, a relative of Kubernetes or something like that. This gives us a lot more control of the deployments. It still lets a lot of the basic security be handled by AWS. And then for the database, we use Postgres. And it's simple, everyone knows it, and it's blazingly fast, and we have all the control we need over our data models. All right. So how does this look in the end? So in the end, we have this wonderful little tangled mess of different subsystems. And Benchling is still in there, so we still have Benchling as one of the third-party integrations with our system. But we also have integrations with GNART, Atom. We can output various different kinds of files, for instance, for the Hamilton. And we have integration with storage. And this is all, yes?
You asked about do you want to just define who GNART and Atom are?
Sure, yes, sorry.
What function they play?
Yes, sorry. So GNART and Atom both are, DNA synthesis providers. So if we want some DNA synthesized, we don't necessarily have to we obviously don't have to do that all in-house. We can get it from Atom or GNART. Lately GNART for whatever reason. So this is all broken down. The code itself is broken down into three main sections. We have the REST API,
which is just a Python framework these days using Fast API, which is similar to Flask for those that know it. And that is what provides the main interface with our database and also with our other main pile, which is the functions. So these are the things that primarily run on the Lambdas, and they're what does most of the integrations. So we use the Benchling SDK to interact with Benchling. And we have a bunch of integrations with AWS, and of course, just a lot of things through API requests. And then the front end is implemented in TypeScript using the Material UI library in React. And all this is, of course, hosted on AWS. Any questions on this part before I continue? All right. So now we're getting really into the benchling. So this is what our integrated data model looks like. I'm not necessarily going to go over each and every bit of this, but the main gist is that it's built in two parts. We have the central data model in LAMP, and this is our source of truth. So unlike Tessera, we actually have Benchling serves mostly as a mirror of what we have in our database. And we do that by pushing results into Benchling at various different points in the process.
I might just sort of modify that a little bit. Benchling for the lab has hundreds of entities and thousands and thousands of details. What's central in LAMP is really the definition of the constructs,
right?
Specifically, so
yes,
how we're making what an mRNA looks like, the sequences and the parts.
Yeah, and so yeah, sure. I should clarify. For where there is replication, where there's duplication between LAMP and Benchling, LAMP is the source of truth. There are things that are in Benchling that are not in LAMP, and if it's and that's the case, obviously Benchling is the source of truth. And I'll get into a little bit more where that plays in. In LAMP, so yeah, we keep track of the sequences, the relationships between the different parts of the construct and the orders. We keep track of the manufacturing status and QC data. All of that is held in LAMP, and the source of truth is in LAMP, although it is also, most of it at least, is also reflected in Benchling. And then in LAMP, as I said before, you're able to order the plasmids, you're able to check inventory, and manage the supplies of actual physical parts. Then on Benchling, so as we mentioned, so that's where we have our ELNs, that's where we have our lab notebooks. It's where we can easily visualize sequences. We can do a lot of sequence comparison. We also are able to connect to experiments in general. So any of the experimental data, any experimental notebooks, any of the sort of somewhat less structured kinds of paperwork and process management that goes on, that happens in Benchling. So things like INVs or forms that people fill out to request experiments, all of that is on Benchling. And occasionally, although we try to avoid it, Benchling is also where anything unstructured goes. So we try to have some structure for everything, but inevitably there will always be some nooks and crannies where someone needs to do something, or at least feels they need to do something unstructured. And it's better to have that on Benchling than on a random file on a random hard drive somewhere. All right, so let's take a quick look at what this will look like in practice. And it's a lot of slides, but I'll be just zipping through. So this is the main dashboard for a LAMP. You can see the list of different constructs. And if you want to create a construct, there's a couple places where you can do that. And you'll enter into this form. So as you can see, this is a very custom form with a lot of fun features. We have our own UX designer, or we've had a UX designer at any given time who has worked with us to design all of the interactions and help make sure that it's nice and easy for the users to navigate. And then once you filled out the form and you hit submit, then the request goes out to a Lambda. So some of it is processed immediately, but a lot of it ends up going out to the Lambda for a bit slower, somewhat slower processing. And then after your construct is designed, the Lambda will then submit various entities to Benchling. So you'll end up with a plasmid map, and you'll end up with a plasmid lot, and a construct. So you have different representations of either the full sequence of the plasmid, and then the sequence of the construct as it will actually be in its final product. And then when you validate a construct, similarly, this is basically the manufacturing tracking that we have in LAMP. So at each stage, so you have stages and substages, and in each stage you have some pieces of information you often have to fill out, some required, some not. And finally, when you move your constructs through the entire pipeline, at the very end, you run your analytical panel, you've entered in all your QC data, and you hit complete. Then the construct is now done, and that goes out to a Lambda for some final validation. And assuming validation passes, you get a construct lot in Benchling. So this is how we have both our data primarily represented in a separate system, but we also make sure that Benchling is synchronized with what's going on in LAMP. As soon as the action is taken, we trigger the process that pushes things to LAMP. Now, of course, pushes things to Benchling. Of course, there are faults, there are things that don't work. Various kinds of failures can occur, and we'll sort of come back to that later as to some of these we might have wished we done differently. Last but not least, each construct is made up of discrete parts. This is what we use to help organize the design of the constructs, and these parts, when you create them, also go through a Lambda and have a representation on Benchling. And and then increasingly, we're only sort of just getting into this, but we're also adding more links to Benchling from within the LAMP application. So if you want to look at that representation, so in particular, as I said before, Benchling often has much nicer views of sequences. This lets you access that without us having to re-implement it. So looking back overall, this approach really gives us the best of both worlds. We have our custom system in LAMP, which gives us complete control of the data, and we get to fully and completely design the user experience with the help of a professional UX designer. We have a lot of opportunity for nice and easy integrations with third-party vendors, and we can sort of choose the extent to which we optimize our responses. So for large responses, we can still get, for large requests, we can still get a rapid response to whatever degree we feel we need. On the other hand, we still have Benchling. And so we don't need to reinvent the wheel for ELNs. We don't need to reinvent the wheel for sequence visualizations. We have access to a lot of the sort of biospecific tools that are integrated into Benchling. So we have the ability to do the alignments and to do the sequence searches. But not everything is perfect. Some of the things we kind of wish we'd done a bit differently. As I alluded to before, we probably would have been a bit more thoughtful about letting us do synchronizations manually if we were designing this from the beginning, because far too often things do go wrong, and trying to clean up that the results of that going wrong can be difficult. We probably would have avoided data intake files from the beginning. Is something that's been a recurring issue. Is people creating CSVs or Excel files and trying to upload data with those. We probably would have focused on automation first, being the thing that LAMP does in particular that Benchling does not. And I think the big one, at least to my mind, is we probably would have been a bit more thoughtful about how we implemented permissions from the beginning. Because that's something that, although right now, LAMP being the source of truth manages most of our permissions, but the way that those are organized is a little bit messy and makes it very hard to parse who can do what. And then last but not least, looking ahead, so the merger between Senda and Laurent has the dubious distinction of being the largest merger between two Benchling tenants that they've ever performed. It has been an interesting adventure. And in part, as a corollary to that, we are going to be having to deploy an entirely new set of benchling schemas and integrate with that new set of schemas. And then nothing in life is certain besides death and new features. With the new emphasis on prioritization, we're actually going to be integrating a lot more with benchling, a lot more link outs, as well as more link ins actually. So taking stuff from benchling or requiring data from benchling to be filled out, requiring certain forms or certain data structures in benchling to be present to be able to proceed in LAMP. And just in general, each new feature is an opportunity for better or worse for integration with benchling. And that's my talk. So thank you very much. Any questions?
I'm kind of curious about how your custom side was actually built. So you mentioned two things like using React material, but then you also mentioned LAMP, which to me means building server-side interfaces in PHP, but that's probably not what you mean.
Yes, sorry, perhaps that wasn't clear. So the question is, how do we manage the actual building of the application, of the custom application? And there is also some confusion about LAMP. So LAMP is the name of our main backbone. It, I believe, originally stood for Laurent. Oh, you created the acronym, didn't you? It's your fault.
I created the first version of it way back when. So everything else he said, yeah, this was a bad idea, we threw it out. Yeah, sorry. But included the name LAMP, which, because the company was, at the time was Laurent, so it was Laurent Manufacturing Platform. So that's, again, not to be confused, because scientists weren't going to worry about Linux, PHP, so yeah.
But just to round out the rest of the question. So in terms of how we develop it, we have a team of contractors that works with us in developing it. So we have a couple of front-end devs and a few back-end devs. And together we work on actually producing the various features in the application. And of course, the UX designer, as I mentioned, is part of the same contracting team.
And I think one of the interesting contrasts between these two talks, right, is Dave doing most of the retool stuff, plus a couple other engineers with a low-code UI sort of mechanism. On this project, got a fair number of engineers for a fairly long time, with always the presence of at least a part-time UX designer, which has been awesome. It's really important to have that role. It's been, you kind of put it in bold, but kind of to emphasize that that's why that's important. But it also means, but everything there is built React, JavaScript with some widgets, but pretty much everything's been built. And so it's really there's two sides, and it does take a lot of work to build that framework. And so you kind of sort of decide sometimes you don't know at the start. In fact, this was supposed to be a lot smaller.
Yeah. Well, and that's actually, I think, another key difference. I think our digital backbone is, I'd say, quite a bit older than Tessera's. I think Tessera was just benchling until a year and a half.
Well, since I started, which was about 2 years ago.
Okay, 2 years ago. Time flies. But yeah, so this application's been in development for about 4 years. So it's about twice as old, and it's consequently, as I say, there's always new features. It's drifted further. You had a question.
Yeah, so I actually have a question regarding in terms of the system right now you are using. How many of RNA you are handling? One thing is, I suppose this RNA you producing and designing eventually will become one of the drug. And in terms of the process, how many RNAs, the system is handling and doing this kind of process flow.
Yeah, no, it's a good question. So the question was how much RNA/DNA are we handling? And to clarify, that we don't often make too much of a distinction between the two, at least for the data side, because it's essentially the same as far as we're concerned. We have, so there's sort of two avenues, as I said, right? There's the high throughput, which is sort of, throwing it all out there and seeing what sticks. And that produces the vast majority of our RNA/DNA sequences. And mostly from those, we have, let's see, over 10,000 now. different RNA constructs. And of course, for each of those, we have, a handful of different parts, like 10 or so different parts, and there's a bunch of overlap and mixing and matching. And the density of those relationships is one of the things that we really get to benefit from Postgres, because that, we're able to represent that cleanly and without too much performance, or basically no performance hits, at least at the scale of 10,000. So yeah, I'd say that's about 10,000 or so. Any other questions? Yeah.
It's a question on like you said you use like the LAMP framework to like push up like creating entities or like, updating entities.
Mm-hmm.
Or like users allow us to update entities and benchling and like how that like gets
Yeah, it's a good question. So the question is, I talked about how LAMP can update entities or create entities in Benchling. The question is, what happens if someone updates the entity in Benchling, and how does that get back to LAMP? The answer is we don't let them. So LAMP being the source of truth, the entities in Benchling are locked down, so they're not able to be modified, at least not by any of the standard users. And in general, in fact, if LAMP wants to, say, replace an entity or change it, we usually just delete the old one and create a new one. Yeah, that's essentially it. We just very strictly enforce that LAMP is the source of change, is the source of truth, and Benchling is simply the client of it. And again, to clarify, this applies to things like constructs and sequences, things like lab notebooks and process documents. Those stay more in Benchling, and those really don't have the same behavior.
So in the new data model, so again, we're preserving the obvious best practice, because it's like, no, you can only edit it in one source of truth. But there are some things like the RNAs are always in LAMP. Like we have a business rule, that's where they get created. There are some other things, especially in the formulation side, that you can create it in Benchling or in LAMP, or sort of a tangent to LAMP, but not the same entity. So both could create and register their own or get unique IDs, but you don't get to edit it in one.
Yeah. All right.
Anything else? Awesome.
All right.
Thanks a lot. Appreciate it.
Thank you.
You want to Zoom?
Yeah.
So hi everyone, I'm Tarun Saxena. I am at Ampersand Biomedicines. I've joined in January 2024 this year as an AI data engineer co-op. I'm also pursuing my master's in artificial intelligence from Northeastern. So I got introduced to Benchling just 4 months back, and our company is relatively new to Benchling, and me and my manager are really trying very hard to apply new things to Benchling and learn more about it. So that's one thing we have created is Benchling registration automation that allows users to register entities and at one click. So let's start by what are the problems basically. So what we have, that's our bench scientists have a template in an Excel sheet probably that have the entities that they need to be registered, and they do it, and then they go to Benchling and register them one by one. This has seen that there is a manual registration error, and it's time consuming for bench scientists because there are many entities and they need to register properly. Solution that we have created is an automated registration app that can register multiple entities at once, and it's a streamlined process, so it's a user-friendly process. It doesn't allow users to interfere that much. You just need to upload an Excel file and then click the button register, and it will register the entities. And it enhances efficiency of the bench scientist. And the one thing that I really like about it, it checks for the existing entry checks that if in that Excel sheet an entry exists that has already been registered in Benchling, it will provide you an interface that you need to register only new entities, and this has been registered already. So there are multiple automations that we are creating in future, but right now I'm going to talk about the plasmid chain protein registration that we have done. So I'll directly go to a demo. The live demos are very risky, but
I'm impressed.
So this is the basic, the front page that we see. I don't think you can see the names, but these are multiple automations that we are trying to do. And one we have done is Plasmid Chain Pro. This, we don't have the time to hire the UX engineer for this, and I was very impressed by the sale, what they have done, but this is all me. So very sorry about this. So we, in this, the bench scientist can first choose a creator. These are the names basically of the Benchling users that they create. And then we have, so I can select my name from this. And over here, I can select the sheet that we have, like this. And we just click register, and it will register all the entities, Plasmid, Chain, and Pro, all at once. And it will provide you a nice interface that we have, that you can click the links on them, and then they will redirect us to the Benchling links that they are registered over there. So the sheet looks like this, in which we have the plasmids, chains, and all the entities that we have that you want to register. I can, until the demo works, I can show you what the registration workflow looks like. So when you provide the sheet, it will register plasmid, chain, and then autofill the translations between them, and then we'll update that particular chain, and then register the protein. And this is all done using Flask and Benchling SDK. And for the front end, we are using Bootstrap and SDK. Now let's see if that has been registered. It's registering.
Like I said, if anything goes wrong, it's CrowdStrike's fault. Still recovering.
So we also have this help page, in which we can, it redirects to a Notion page in which you can see all the user-friendly. Oh, it did.
You shouldn't be so surprised.
No CrowdStrike fault. So over here, we can see that it registered multiple entities, and if you click on the one of the entities, it will give you that particular entity link. So you can go over there and see. So this is basically the interface that I've created, and it provides. So it's currently still in the test case. So we are testing it with multiple bench scientists, and they have tried it, and it has been proved useful for them. So it's nice.
Have you had a chance to measure how long it took them to do this manually before your app was created?
So manually, it's like the error-prone process. So they have to do it like one, they will registering, they would have an Excel sheet on the side, and they will be registering entities. So it usually takes around 1 to 2 minutes per entity. But over here, we can see it registered quite quickly, and it can register multiple entities. So it's pretty fast than that. And it's a long run process. So if there are multiple entities that they want to register, like there are multiple around. So for SDK, it allows around 2,500 entities at once. So if in the longer run, we allow like multiple entities to enter, so it will be less than what they have to do it manually.
Yeah, no, I'm sure it wins. I'm thinking, like, I find it really useful to actually go through and time real use cases when you kind of first have the scientists show you what they're trying to do. Mm-hmm. And then you come back later and you say, here's a spreadsheet that has all your data starting from the same starting point. And this took 1 minute, and it took you 2 hours or whatever it is.
Yeah.
So I was just wondering if you happen to have done that. It's always a fun thing to do.
Yeah, sure. So the challenges I will talk to you about is the Benchling documentation. If anyone has done basically SDK, use Bestic SDK, it really provides informative error messages so that you cannot infer what is basically the error, and you have to contact the Benchling support. So kudos to the Benchling support team who have been responding to my bombarding email messages for the errors. And so yeah, that's pretty much it. And in future, we tend to authenticate the users because currently this is running on my EC2 instance. So we can run on our AWS and provide a listener rule so that it can authenticate through Cognito or something. Yeah. So it will provide with helpful to the company. Thanks.
Awesome. Any questions? So I think what's really interesting about what you've done here is a super common use case, which would be nice if Benchling could build this in, but there's a good reason. But there's always going to be need for apps like this, which is like, I don't know if you guys have it, where you have multiple things that are all related, but the scientist thinks of them as one row that has different columns. But the different columns are actually going to be different entities that are going to then be connected to each other. And so to do that manually means you have to sort of take these columns, register, get the results. Those IDs need to go back into your parent entity. And so that's, I think, maybe so the unsung hero here is the fact that you're chaining all these things together all in one shot allows the scientists to sort of think in one dimension. Again, like Dave was talking about, you may have a different way of thinking. The data model, the way Benchling has it, is great. But, normalized essentially, but scientists think denormalized. Or just flip that upside down, Any other thoughts on this?
I want to mention that, I'm Matt here. This is not the only use case that we're building this for. There's like 2 or 3 other sets of entities that suffer from the exact same problem, and the scientists are reluctant to spend hours registering multiple entities, all that are related in different tables. And when we reached out to Benchling about this initially, they wanted us, they were trying to push us towards like, well, we could use that Benchling has some mechanisms to handle this, right? They have this table mapping thing, they have an app structure table, and then you do like number of repeats for previous entity and stuff like that. Those we felt were like band-aids on the problem. They still didn't really, address the core issue that because web scientists were making these sheets in the wide format anyway. So they're they use it, for instance, in this case. This is the format that they send it to vendors for when they order a lot of these like data sequences or blocks stuff like that. And so they're making these SLPs anyway, and then they have to translate that into what Benchling expects. So we figured that this is this kind of mechanism is very useful in this case. It would be great if Benchling would support something like this, like on a more general basis, so that we do have a little bit of apps. But it's also nice that they do have an SDK that allows us to do something like this.
Yeah, and I think my thinking is that in the future, fast forward some amount of time, we'll always need these types of things. And it would be helpful for some cases where I have a concept in a batch, they're all together, and I want to keep it be a normalized data model, but you expect it's normalized. You just say, yeah, here's the spreadsheet. These columns and these columns go here, these go there. Just do that for me. I think that's a fairly generalizable case. Maybe if I thought about it further, fine. I mean, I've done that in other Win systems. It seems to be fine. Again, you can, as you step on the border to find all the weird things. But for the mainstream case, I think there are a lot of uses that are good to have it built in, and the sort of things that have cases where you want to do other things, and have special validation rules. Awesome. Well, thanks so much. This is really good. Appreciate it. So thanks again to all 3 of our speakers today for volunteering, and it's not just like the hour or 2 to come here at this time preparing for these. And actually, I saw Patrick your slides the other day. I like to preview them, and these were totally different and clearly spent a lot of time making the better. So I appreciate that, and I think hopefully everyone else does. We are recording this, so other people will see them. So it's also getting sort of broader benefit. Anyway, so thank you all for participating and volunteering. That's super helpful. It enriches all of us. And thanks all of you guys for coming and showing up and turning out, because you never know. We're just figuring out what's going to work with these user group meetings. So I'll be repetitive and say, again, please let me know feedback on this event, what worked, what didn't work. I already got AV on my list. And ideas for future events, if you want to speak, whether it's a short little lightning talk or a long topic, or even something that's not even presentation, you have ideas, just let me know. I think that's about it. Anyone have any other thoughts, questions, suggestions? Shut this down.
There's a couple of questions in the chat.
Okay.
There's one question in the chat. It's, I think to me is, have you guys built interfaces to set up 96 roll plates? Yes, we have, and we've actually done it in a way to make it like the use case that you guys have is we do it in a layered fashion. So you can say that these one layer of the, so it's almost like tabs in an Excel sheet, and it's a plate format. So like if you're an A1 and one plate relates to the A1 on the second tab, and those things get combined into an entity. And we did that with the hands and tables.
Yeah. So, and interestingly, Benchling's got some nice new plate map capabilities too. So, it'll be, 6 months from now, it'll be interesting to look at how much does, because if Benchling didn't do what they've just done in plate mapping, I think there'd be a lot more work because it's a really important need, that's plate mapping. But now maybe it'll be a little bit less so for some use cases, and then there's others where, and I've seen Dave's demo of that, and it looks pretty slick. And again, once you kind of break the ice, and he's obsessed about this stuff. Like once you kind of get in, it's like, oh, like I got the framework, and I can do my hello world, and I can do this thing. Then, oh, let's see what happens if I plug SeqViz into it, or I got this table, so let me see if I can do a plate map, and you kind of get addicted to it. So. Anyway, thanks everyone. For people on the remote, thanks for joining, and hopefully it was tolerable. I know it's kind of weird the way it was set up, but, and hopefully we'll do this again and take your ideas. Have a good night. And there's more food back there too.